Okay, so we're going to continue looking at dividing fractions using models. This video is specifically going to focus on whole numbers by fractions, and to help do this a little more, we're going to be diving into real-world problems to help us visualize how these models are being used. Okay, we're not going to use this packet, so just keep hanging on to this packet until we get back to school. All the problems you'll need for today's assignment will be on the Google form, which is where you found this video. Okay, so I'm just going to have it here on my phone, and I'll be doing the math here. So please find any paper at all, scrap paper. There's backsides to all of these if you need to. Find somewhere just to draw these models. Okay? So, number 1. If a turtle can move 1/2 mile every hour, then how many hours would it take for a turtle to go 9 miles? Okay, so I've talked about cubes with some of you before. Now this is online, so I can't physically do it, but this can help us process these story problems, real world problems. Got to start getting used to that. So C stands for circling our numbers. So let's think about our numbers. We're working with 1/2 and 9. Okay, so somehow we're going to make an equation to set those up. Underline the question. So let's think about what it's asking us. How many miles will it take a turtle to go 9 miles? So we're wanting him to go 9 miles. We're asking how long, knowing that he goes 1/2. Okay. In this case, boxing any math words, since it's saying every hour, we know we're going to have to do something there. We're going to see how many 1/2s can fit into 9. And that's the question that drives our division problems with fractions. How many can fit? So we know when we evaluate the E, we're dividing. What helps you today is know we're dividing everything. Okay? So now let's set that up to a problem. Let's go ahead and solve it. Okay? So everything I write, you should be writing. So we know they're trying to go 9 miles total, and we're seeing how many hours it's going to take him if he goes 1/2 hour. Okay, so that's our problem here. All right, remember the first step is just to draw the first number. In this case, the first number is a whole. Because it's a whole, we're going to draw how many are there up there. There are 9. So draw your 9 holes. Remember, in the video you can pause whenever convenient for you. Try to draw them as best as you can. Okay, so that's step 1. Step 1, draw your holes, or your first number. Step 2, kind of going to be a little different to try to combine some steps to make it easy for us. You're going to look at the denominator and just split them, when it's the holes, split them into whatever that is. So these are halves. 2 parts, 2 is in the denominator. Okay? So then step 1, make our holes. Step 2, make your holes split into whatever the second number fraction is showing you. Then ask yourself, how many 1/2s fit in 9 holes? That's what this division problem is saying. How can we split 1/2 from the 9 we have? Okay, so all we need to do is count 1/2. So here's 1/2, here's 1/2, here's 1/2, here's 1/2. We're just going to essentially do that until we run out to see how many halves fit in that hole. So we're at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 1/2s fit into 9, or in this case, how many hours will it take him to go 9 miles? 18 hours. Okay, so we have our model drawn. Now we need to make sure, let's go ahead and check it. Okay, so I'm going to put it over 1. I'm going to keep the first number, change to multiplication, and flip the second number. Okay, some of you are flipping the first number. Make sure you keep, change, flip. Memorize that process, which equals 18 over 1. So we drew our model correctly. All right? So Go back if that didn't make any sense if you need to. Run through it again and then go ahead and type in your answer of 18 hours into the blank. Okay, going on to number 2. Again, remember, so you have these on yours, but we can just read it together here. Benny is cutting, it's freezing up here. Benny is cutting bows out of ribbon, which will be used to wrap some gifts. If Benny needs 2/3 of a foot of ribbon to make a bow, and he has 8 feet of ribbon, then how many bows can he make? Again, think about those numbers. C for cubes. Numbers, we're working with 2/3 and 8. Okay, so most likely we're seeing how many 2/3 can fit in the 8, but when we get to evaluate, we'll figure that out. Underline our question, evaluate it. How many bows can Benny make? Okay, so out of the 8 feet he has, each bow is 2/3 of a foot. We need to figure out how many he can make. Alright, how many he can make is a math word that's going to help us out. Evaluate it, just like we said, we're dividing it. So let's go ahead and solve. Okay, so again, our whole is 8 because that's what we have so far. We are splitting it into 2/3 and we're seeing how many 2/3 can fit into 8. So that question is, we can start right from the start. How many 2/3 can fit into 8 holes? Okay, so let's go ahead and set that up with our model. Okay, remember the first step? Drawing the first one. In this case, it's 8 holes. Because there are holes, we can just draw the whole 8. The next video will talk about when it's fraction by fraction, and you won't be drawing more than one fraction bar. Okay, but we have our 8 holes. Second step, do the denominator. In this case, we need 3 parts in each hole. Okay, so now I have 3 parts in each hole. And then remember our question, how many 2/3 can fit into 8 holes? So this time we're circling 2/3 grouped together. Here's 1/3, here's 1/3. That's 2/3 grouping it. 1/3, 1/3, grouping it. 1/3, 1/3, grouping it. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Okay, remember if I went too fast there, just pause it and get caught up and then hit play. Okay, so then how many 2/3, how many groups could we make? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 groups, or like our question asks, how many bows can he make? Benny can make 12 bows. Okay, let's go ahead and check it. Put it over 1, keep, change, flip. 24 divided by 2 equals 12. Bingo, we got our model correct. Go ahead and type in 12 bows to number 2. Alright, and then the last one. Let's see if I can fit it right here. 3. One teacher wants to give each student 1 1/3 slices of pizza. That's odd, but if the teacher has 4 slices of pizza, then how many students will she be able to hand out pizza to? Alright, let's think about the numbers. She's dealing with 1 1/3 slices out of the 4 she has total. There's probably an easier way to do this, but let's go ahead and solve it. We're wondering how many students, that's our question. Math words, if she'll be able to hand out to, that kind of tells us we're dividing again. Evaluate it, just divide and solve. So she has 4 slices that she wants to share into 1 1/3. I don't know, fractions, right? Alright, so this one looks a little different. It's going to be the same process, we just have to do one extra more step. We need to change this to an improper fraction. Multiply, add. So now we're going to have 4 divided by 3 times 1 is 3, plus 1, 4/3. Okay, and now everything is just the same. Make our whole. 1, 2, 3, 4. split our wholes into whatever the denominator tells us to. 3 parts for the denominator. Alright, then ask ourselves, how many 4/3 fit into 4 wholes? Okay, same process. I have thirds here, 1/3, 1/3, 1/3. So I just need to count them by 4 this time. 1, 2, 3, 4. Here's 1. 1, 2, 3, 4. 1, 2, 3, 4. Alright, so how many groups did I make? I made 1, 2, 3 groups. Or that means she can share the pizza with 3 students. Let's go ahead and check that. Over 1, keep, change, flip, equals 12 divided by 4 equals 3. They match. Our model was great. Okay, so again, this was modeling, looking at real-world problems when we're looking at whole numbers divided by fractions. The next video after this, so numbers 4, 5, and 6 are going to be about fraction by fraction. Okay, bye.